Okay, hello everybody. Welcome to Ultramind Academy. So, today we're going to learn about quadratic equations. Another word for quadratic equations are trinomial equations. Okay? Trinomial equations are an equation with three compartments, like x squared plus something x plus something. Quadratic equations is also in that format. Okay. Uh, the quadratic equation format is like ax squared, where a is the front coefficient of the x squared, plus bx plus c equals 0. Then what is x? So quadratic equation, what you need to do for the factoring method, so this is the factoring method, guys. So what you need to do is that you're going to factor and you're going to make it in this format. Answer is always 0, so quadratic equation has two answers. But one of these brackets must be 0, but the other doesn't have to be, because 0 times anything is 0. Okay? 0 times anything in the whole universe equals 0. So that's why it has two answers. Okay? So now we are going to use the distributive property number 1, and we're going to discover about quadratic equations. So like, it's just like basically like packing up. Distributive property is like unpacking and like expanding brackets. So let's have x plus 2 times x plus 5. So there you have it. It's x squared. So firstly, x times x plus 5 is x squared. X squared plus 5x. Okay. And then now what you do is 2 times plus 2 times x plus 5. Okay. So now this is 2 times x plus 5 is like plus 2x, and then plus 2 times 5, which is 10. So now what you need to do is that you're going to add up these like terms, okay, because they have the same variable. So you do 5x. So now 2x plus 5x, what you get is 7x. And let me firstly erase this rubbish. Okay. So x squared plus 7x plus 10. Okay. So we can see that 7 over here is the sum of 2 and 5. And 10 here is the product of 2 and 5. Like the constant at the end without the variables, that is always the product of these things. Okay? Even cubic equations, quadratic, or any polynomial equations. And this is the x squared plus 7x. So 7 is the coefficient that goes before the variable, its number. And 7 is the sum. Okay? So now we know what b is. B here in format, b is 7. So b is the sum. And then c, and then afterwards c is the product. Or prod for short. Let me write down product. And the a, we're going to know what a is later. Okay? This is the first distributive property. And now let me bring the let me get you some practice to expanding brackets and then know more about the pattern. So this is x squared. So x squared plus 3x. That x, like this x times x plus 3, and then afterwards 4 times x is plus 4x plus 12 equals x squared plus 7x plus 12 equals 0. So that x 7 is 3 plus 4 and 12 is 3 times 4. And also another problem here, x plus 7 times x plus 3. So solution, it's obviously x squared because there's no 2x, and then what's 7 plus 3? It's 10, 10x. 7 times 3 is 21. Okay? So these are some practice with the distributive property. Now what we have to do is that we have to find a proper way that sum equals b and product equals c. So it's a quadratic equation, just like a problem saying, for example, Jill and Jill's and Tom's ages add up to blah blah blah, and product of the ages is blah blah blah. Okay. So distributive property, this is actually called the binomial equations. And I'm going to show you what it is 1 minute later, or probably 10 seconds later. So for example, sum of A and B equals 14 product, which is just basically A times B, or AB, equals 24. What are they? Okay, so what are they? Okay, so now what we need to do is that we actually can figure it out this way. Like the average, what's the average of A and B? It's obviously 14 divided by 2, which is 7. So we can represent an unknown number, for example, like 7 divide average, and then minus something, and then plus something. These are two numbers, and product is 24. So we can represent that unknown number, u, 7 plus u times 7 minus u. Okay, so that is equal to so guys, this is the second concept in quadratic equations, or distribute. So this is a binomial. So over here is like 7 squared minus 7u plus 7u, and then minus u squared, and then these guys minus 7u plus 7u cancel out. So then 7 squared minus u squared is 24. So it's like 49 minus u squared is 24. So u squared is obviously 49 minus 24, which is 25, and then u is plus or minus 5, guys. So it can be either way. 7 plus 5 is 12, and 7 minus 5 is 2. But if you do like minus 5, it's like just basically the same thing, except these two are swapped. So then that means that it's x plus 12 times x plus 2. So then obviously over here x is minus 12 and or minus 2. Okay. So this is the distributive property 2. Now we can combine the ideas, the theory plus how we do the sum, and we're going to now make it into quadratic equations. Actually, actual quadratic equations. Solving actual, solving quadratic equations, solving actual quadratic equations. Let's put it here. Okay, so solving actual quadratic equations. So, for example, let's say this thing. This is actually very, very common. I saw many teachers using this problem. X squared plus 2x minus 8 equals 0. Okay, so that this is x plus something times x. Now, because there's just a minus over here, it's x plus something times x minus something. Like, because minus equals plus times minus. So now we're going to find two numbers. Sum equals 2, and then product is equal to minus 8. Okay? Okay. So, what we have to do here, 2 is broken down into 1. Okay, 1 plus u times 1 minus u, and then that equals minus 8. Okay? This is basically like saying Jill and Tom's age add up to 2 and multiply up to 8. What are their ages? So let's start solving it. Okay, so x 1 plus u, so this is equal to minus 8. That means that u squared is equal to 1 minus minus 8, which is basically plus 8, which is equal to 9. That means u is the square root of that, which is 3. So, 1 plus 3 is 4, and 1 minus 3 is negative 2. So it's x minus 2 plus, and x plus 4. Okay, so over here, x plus 4 is 0. That means that x is minus 4. X minus 2 is 0. X is 2. Okay, so this is the solving actual quadratic equations. Okay, so let's now continue into our second problem. What happens if it's not x squared? What happens if it's 2x squared plus 2x squared plus what happens if 2x squared plus 4x plus 624 equals 0? Yeah, what happens if it's 2x squared? Well, you can go like 2x plus something and times like x or something. You could do that. However, what if there's a number that has many factors? For example, like 96x squared, 288x squared, or even 1152. Let me add a 0x squared. Things are just getting too complicated, okay? So, So what we have to do is that we're going to divide the whole equation by this answer. But it can't be 0 because you cannot divide by 0. So then it becomes x squared plus 2x plus, sorry guys, this should be 1248. Yeah, so this is plus 624. Now this became our simpler equation. So at the start, this A will be the divisor, so dividing, and then now we know that B is actually the sum after dividing, and then C is the product after dividing. So 2 divided by 2 is 1, the average is 1. 1 minus u times 1 plus u is equal really sorry guys, it should be minus. I should have prepared before I done it. But this is minus, okay? This is minus. So it equals to minus 624. So 1 squared, 1 minus u squared equals minus 624. U squared is 1 minus 624, which is basically 1 plus 624. That will be 625. So u must be 25. So 1 minus 25 times 1 plus 25. Okay? So 1 plus 25, that is 26. And 1 minus 25, that is minus 24. So it's basically x plus 26 times x minus 24 is equal, that's equal, so x plus 26, x is minus 26, and then x plus 24 is 0, x is 24, like x minus 24 is 0. Okay, so these are two solutions, and if you check minus 26 times 24, or you can just even check 26 times 24, you'll get 624. Okay? So that is this case. So over here, what A actually is. A is the divisor. Sometimes you'll come up with this thing. Irregular square roots. Irregular square roots. Okay? So irregular square roots over here is like not perfect. The square root of not perfect squares, non-perfect squares, probably. So for example, like 32 square root, 1152. Actually, let me 128. Or 2187, and then 1152. Okay, 1152 is a pretty good number. I'm not sure why I'm using it very often. So the square of 32. So what you do is that you're going to look at its factors, and then look at the factors with the even square roots. Okay, with the even square roots. Like the even powers. So it's 2 to the 5, which is So now 2 to the 4, like the largest 2 to 4 times 2 to the 1, like the largest power in the factors, okay? The largest even power in the factors. Okay, so 2 to the power 4, it's like the square root of that is basically 16 square root, which is 4. And now this is just basically like this square root to the 4 times square root of 2, okay? So that is the rule here. So that means 4 times the square root of 2, okay? Now the square root of 128 is square root of 2 to the power of 7, which is equal to square root 2 to the, wait a second, okay, 2 square root 2 to the power of 6 times the square root of 2. So what's the square root of 2 to the power of 6? That'll be a square root of 64, which is 8 times the square root of 2. Okay, so that is for 128. Now if you're not sure what 2187 or what power, it's actually 3 to the power of 7. If you do prime factorization, you'll see this result. So now, what we can obviously see, it's 3 to the power of 6, the square root of that, times the square root of 3, which is equal to, this is 729, guys. The square root of that is 27. So 27, and then square root of 3. Now 1152, this is a little bit trickier because it not only has powers of 2, but it also has a little bit of powers of 3. So let me break it down into prime factorization. Okay. So 1152, if you know, it's actually 128 times 9. The square root of 2 to the 7. And then what's the square root of 9, guys? It's 3. So now we got it simpler. So the square root of 2 to the 7, which is 128, that's 8, 8, and then the square root of 2. We already done it. So that's equal to 8 times 3 times the square root of 2, which is equal to 24 times the square root of 2. So hopefully you guys know how to do the irregular square roots in quadratic equations. If you get irregular square, like non-perfect numbers. So this is how you do it. But if you got a number, you're not sure if it's square, just always break it up into prime factorization and use this method, as it will always help. So now we're going to do something very, very amazing, but I'm not going to tell you yet because I want you to predict. Proving. You might be thinking, proving what? The quadratic. Starts with an F, guys. Hooray, you guessed it. Formula. And you might be thinking, proving the quadratic formula? How can someone do that? That's absolutely absurd. But today I'm going to show you, using the factoring method, how we can prove the quadratic formula. Afterwards, I'm going to be like, ta-da, okay? So this obviously comes in the ax squared plus bx plus c equals 0. So keep in mind now that we are actually going to see that the sum equals minus b, okay? Because it's always like x plus and x plus this positive, like it just does the opposite, which is negative. So now I'm going to say that the sum is minus b, okay? To not waste that much time. And then product equals c himself. Wait, just wait a second, guys. Before we divide, we haven't decided sum yet. Sorry, guys. So we have to divide, but a cannot be equals to 0, okay? We're sure about that, now we can divide. X squared plus b over ax plus c over az. 0 over a is just basically 0, okay? You can put 0 at the numerator, but not at the denominator. Okay, so sum equals b over a, and then product equals c over a. So so now the sum is b over a. So now what we do is that b over, so now we divide by 2, b over 2a plus u, and then times b over 2a minus u. Okay, so equals c over a. So then b over 2a squared is b squared, guys, over 2a brackets 2a and then squared. So 2 squared is 4 and a squared is a squared. So b squared over 4a squared. So u squared is b squared minus over 5 squared minus c over a. That means u equals square root of that. Okay, so now, okay, this is minus b over a. So now what we do is that we're going to bring it back into the minus b over 2a. So now this is plus or minus, okay? And then over here, b squared over 4a squared minus c over a. Ta-da! We proved the quadratic formula. Just joking. This is actually the quadratic formula. We put numbers in at work, but this does not look very familiar. Okay? So we have to clean this thing up. Minus b over 2a. So you find the lowest common denominator. So it's 4a squared. Okay? Because 4a squared divided by a is 4a. So c is over a. Now we have to times by 4a, because as I said, 4a squared divided by a is 4a. So now it's b squared. So now what you need to do is that you're going to do this. Like that. So that is actually the rule in algebra. Only for multiplication and divisions, guys. Only for multiplication and divisions. Okay, why is this 4 not neat? Okay, finally. So now the square root of 4a squared is 2a. So now this formula over here, this already looks really familiar. All we have to do now is to join up the whole equation. Join up the whole equation. Okay, so now therefore this is what we get. Minus b plus or minus b squared over 4 minus 4ac and the whole equation over 2a. Ta-da! I used the magic and proved the quadratic formula. Sound the trumpets, musicians, play the pianos and drums. We have proved the quadratic formula. So now you can tell your teacher to give you an A plus because you had proven the quadratic formula and you have done a great job. So let her give you an A plus in your next test. Okay. So this is actually pretty amazing as we have learned about a new concept in the quadratic equations, which is about factoring method. It's invented in the 21st century by a mathematician called Potion Low. Not only to prove this, but also to let you understand more about the factoring method and how oversimplifying it. So, thank you everybody for watching. If you like this video, please like and subscribe. And don't forget to turn on the notification bell to look at more videos. Thank you everybody. Cheers from the Ultramind team.